Okay, so in part 2, I suggested that you check this answer just to kind of see where we're at as far as money goes. So again, what did we get for an answer? I think it was 40, right? So what you're going to do is you're just going to sub in that 40 right there and do order of op going forward. So you can take 1.2 parentheses, what do I have, $6.50 plus 25 cents times we ordered 40, end of parentheses, and then we get what? On this side we get 19.80 or 0.8, sorry, or $19.80 if we're thinking of money, compared to what, 20. Now I know they're not exactly equal, but notice what happens if we put 41 in there. If I put 41 in, then we spend $20.10. So you'd have to end up borrowing a dime from another diner. So you can really only, because you only have $20 and you can't go over it, the answer is still 40. So when you check it, it's not, because we rounded, it's not going to be exactly 20. But the answer is still 40, because if we do 41, we're going to run out of money. All right, let's go down to this next one. All right, so again, we're going to get a little more real because you have to pay tax as well. So again, we do not ever want to do this because we want our equation to tell our story of what happened in the order in which you read it or the way it behaves. So again, I'm going to have you pause, go ahead and write an equation for this, and then we will go over it together. Okay, so let's go ahead and see what we have going on here. So again, real life, what happens? I order my drink. Real life, what happens? I order some wings. And then after that, oh yeah, I had my dipping sauce in there too. And that makes up my bill. And then after that, let's see, assuming you'll pay 7% and you want to buy a pitcher and you're going to leave. Okay, so then I'm going to end up paying my tax, which is 1.07, because remember 100% and 7% makes 107%. And then on top of all of that, and I don't know that I'm going to run out my screen here. I don't know if I can. I might have to hook it back up to my mouse to move my video screen over here. Let me see if I can do that to create more space. Yeah. So then in addition to that, I would need what? Another, let's see, then the 20% tip. So 1.20 on top of that. So again, I have the bill, which is made up of drink, sauce, and wings. And then I have my tax, and then I don't know where my 120% went. It just kind of disappeared, but for my tip. And all of that has to equal my $20. All right, so again, pause, and there are a couple ways you can solve this. I don't know why that 120 keeps disappearing, but I'll keep writing it. Here, I can rewrite it down here. Maybe it doesn't like being off the space. So there's this part, and again, I can go ahead and get my $6.50. And I'm going to switch to my finger here quick. And I did order batteries from Amazon for my stylus, so hopefully they're probably not an essential item, but they are kind of for faculty. But we will make do until that comes. So anyway, yeah, think about how you could solve this. And again, there's multiple ways. So think about going forward, going backwards, think of properties. Go ahead and try to solve this, and then I will come right back in a little bit. Okay, so one thing you could do is do the math backwards. So you could think about, first I would add in, or first I'd multiply by the 25 cents, then add in real life, get an answer, then I'd multiply that, get a new answer, and then I'd multiply that. So that if you knew how many wings you ordered, that's what you do. So you could do that math backwards if you wanted to. To get rid of the 20%, you could divide both sides by 1.20. And what that would do is, if I take 20 divided by, what is it, 1.2, I get, oh, that's not what I wanted, 20 divided by 1.2. I get that 16.666 ... And then I have that, I I have so that got rid of the tip. Then the next thing I would have done is multiply. So again, I could go backwards and do that math. So I get 650 plus 25 cents W. This is basically getting rid of the tax. And that's why you don't want to round this right now. You kind of want to wait till you're kind of done with that. Okay, so 1557. And then at this point, now you would have to undo adding and subtracting. So to get rid of that, I'm going to subtract. So what am I subtracting? 650. And then what do we have? 9.08 about. That doesn't seem right. What is it? Oh, I probably should round this to 8. Well, we'll see. Yeah, the whole rounding thing here. So we'll do 908. We'll round this according to rounding rules, but then at the end, if we have to change our wings, we will. So divided by, what is that, 0.25. So I get about 36.3, something like that. So still going to round to 36 wings. So that's one way you could solve it, but maybe you don't really want to solve it that way. So, oh boy. Oh, well, that's interesting. Let's see if I can make this big screen. Okay, I'm going to pause while I figure this out. Give me a minute. Okay, so another option is to always use properties, right? Because in order of operation, you can't add these. These are not like terms, but you could distribute and then distribute again. The other thing you can do is you could go ahead and multiply these. You can't add percents. Remember, like if you have a 20% coupon and a 7% coupon, that does not make a 27% coupon. But you could multiply these. And so that kind of gives you those two acting both. So if you have a tip of 20% and tax of 7%, you're paying for the item as well. If you multiply that, it's really like you're paying, what, 28.4%. So again, remember, you can't just add percents, but because there's multiplication here, I could use the commutative property and associative property. I guess associative here, I'm not moving anything, just grouping it. But I could group those together and create that percent with multiplying. So then what you can do is, if you don't want to divide, or you could divide now if you want to, but at this point, you could use the distributive property. So you could do that. That would give you another option. So you could distribute that to that, that to that, and solve. So why don't you pause, see how that goes, and I'll be back in just a second. Okay, so I went ahead and solved this. So again, I multiplied these using associative so that I could get an overall percent, which includes tip and tax. But again, remember, you can't just add percents. A percent of a percent doesn't work that way. And so then I distributed, and I got those. And then at this point, it's just add and multiply. So order of op backwards, I'm going to get rid of the adding first. So I did that to both sides, and that kind of canceled out that part. And then there's no adding left. So at this point, I just divided both sides. Again, these cancel. And then with rounding, I get 36 wings. Now, again, if you're going to sub that in to your original equation, so if you go back to the top and sub that value in up here, it's not going to equal exactly $20. But remember, you know, if you round up, you're for sure going to run out of money. But this is an example where you had to round down regardless. It was 36.3 or something like that. But yeah, you're going to run out of money if you round up, but definitely you might not use all $20. All right. Let's see. Go ahead and try the next one on your own, and then I'll share the answer with that one. I'm not going to solve that one. And then we're going to look at problem number 8. On the next page. Our number 7, just know you're buying the $1.50 dipping sauce too. So see if you can set that up and solve it, and then we're going to talk about number 8. Okay, so here's number 7, including the $1.50 sauce. Here's how I set up the equation, and again, you can solve it similarly to the previous one, and you should get about 21 weeks. All right, I want you to look at number 8 quick, and we'll do whatever time we have left here. But if you have a bunch of fractions, because equations are balanced, if you double the weight on one side and you double the weight on the other, it's still going to be balanced. And so if you look at this first one here, if you have an equation and fractions and you know it's a balance, kind of like a microscope, you can just kind of zoom in or zoom out, and you know the petri dish doesn't change, it's just your perspective. So what you can do is called clearing the fractions. So see how the common denominator here is 8? I'm just going to multiply everything by 8, and I'm just going to scale it all by 8. And so notice you can either take 4 goes into 8 twice and get 6x, or on your calculator you could just take 3/4 times 8 and you'll still get 6. Here I could take 2 goes into 8 4, 4 times 1 is 4, or again on a calculator just take half of 8. And then on this side 8 goes into 8 once, and I get 7 times 1, which is 7x. I'm using the mouse again here. And then 2 times 8 is 16. So if you don't like doing the math yourself, you could just take, again, 7/8 times 8 on your calculator. And so then the nice thing is now you can solve, this equation right here. So if you don't like the original, notice now when you solve this, there's no fractions. You have 6x, 4, 7x, and 16. Now, that doesn't mean your answer might not be a fraction. It just means you don't have to do fractions to get the answer. Okay, so this last one, we don't have a lot of time. Find the common denominator, which is what? Is it 12? So times by 12, times by 12, times by 12, and times by 12. Now, this goes with this, so I have to distribute my 2. So I get 2x minus 2